This is what we did last time. We had land as our fixed input, water as our variable input. And we just kept adding water, more and more units of water to that fixed input land, and we looked at production, output. The first, we had a unit of land and we had no water, so we had no output. Add 1 unit of water, we had 10 units of output. 2 units of water, 40 units of output, and so forth. We kept getting more and more output, but as you can see, at a lower and lower rate of increase. That rate of increase we measure as marginal product. The marginal product tells us when we add 1 unit of the variable input, how much output do we get? And as we can see, adding that first unit of the variable input increases output from 0 to 10, so that's a marginal product of 10. The second variable unit of variable input takes output from 10 to 40, and we divide those changes and we get 30. Okay? So, as we saw last time, at first we had increasing marginal product. It goes from 10 to 30. But then marginal product starts to fall, and that is what we call the law of diminishing marginal returns. Something we'll see in any production process. And the reason for that is, as we keep adding more and more of a variable input, we start to saturate that fixed input. Okay, so that's it. So we're going to continue on now. We've got marginal product. This is our measure of productivity. And that's also stated, we're going to look at the cost of production, and the cost of production depends on 2 things. 1, the price of the inputs, and 2, the productivity of the inputs. Well, marginal product, that measures the productivity of the inputs. Now we're going to look at the price of the inputs. So, the cost of the fixed input is called a fixed cost. So we're going to put fixed cost right here. And the price of the fixed cost, fixed input, we're going to say is $100. So, we've got 1 unit of land at a price of 100. So the fixed cost is 100. We've got 1 unit of land at a price of 100. So the fixed cost is 100. So the fixed input is 1. We're holding that fixed, and therefore the fixed cost is going to be fixed as well. So we'll just write those in here. Okay. Next is the variable cost. That's the cost of the variable input. And we said that the price of the variable input, we're just going to have to be $10 a unit. So, 0 water, that means the variable cost is 0. Then we have 1 unit of water, 1 times 10 is 10. And so forth. 2 units of water, 2 times 10 is 20. Okay, except for I'm getting my columns mixed up. That wasn't too good a placement there. And so forth. 30, 40, 50, 60. Okay, and then total cost is simply the sum of fixed cost and variable cost. So we have 100 plus 0, 100 plus 10, 100 plus 20, 100 plus 30. Okay, let's fill that in. Okay, now that takes us to something that is called marginal cost. Marginal cost is another, we do a lot of economic analysis at the margin. So just as marginal product was a big deal, marginal cost is going to be a big deal here. So what marginal cost is, marginal cost is the change in total cost divided by the change in output. Okay, so let's take a look. We've got output going from 0 to 10. That's a change of 10. And when that happens, total cost goes from 100 to 110. That's a change of 10. So marginal cost there is 1. And the same with marginal product. This is actually taking place as we're moving from 0 to 10. We're kind of in motion there. So as output goes from 0 to 10, total cost goes from 100 to 110, and so we put that marginal cost kind of in between the lines there, in between the 100 and the 110. Okay, so the next one, we've got quantity going from 10 to 40. That's a change of 30. And output goes from 110 to 120. That's a change of 10. So 10 divided by 30 actually equals 1/3, or 0.33. We'll put 0.33 up here. And so on. Okay, we just keep on going. 10 to 40, then 40 to 60. The change of 40 to, excuse me, 40 to 60 is 20. And when we go from 40 to 60, output goes from 120 to 130, a change of 10. So 10 divided by 20, this time it's a half. And that would be just 0.5. Okay, so I think you got the idea. Okay, and we'll just go ahead and fill in the rest. And we've got 0.5, and then this is 1, this is 2, and this is 10. Okay, now this is important to understand the relationship between marginal product and marginal cost. Notice that when marginal product is rising, when we've got increasing productivity going from 10 to 30, marginal cost is falling. Well, that makes sense. If productivity is increasing, the cost would be falling there. So increasing productivity, decreasing marginal costs. But now we've got productivity falling, going from 30 to 20, marginal costs rising. Productivity keeps falling. Marginal cost keeps rising. So these are inversely related. We've got increasing productivity, increasing marginal product. Marginal cost is falling. When marginal product is falling, marginal cost is rising. Okay. All right, let's see. Let's scroll over here a little bit. All right. So now we have, I'm not sure you can see that. There we go. Now we are going to look at average costs. To get an average of anything, you just divide the total by the number of units. Okay, so we're going to look at average fixed cost. And average fixed cost is fixed cost divided by Q. And then we're going to look at average variable costs, which is variable cost divided by Q. Then we're going to look at average total cost, which is total cost divided by Q. Okay, that gets us halfway through the columns there. Let's see how many columns we got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 columns, so we've got only 11 more. No, I'm just kidding. That is that is it. Okay, that's the end. Just to let you know. So average fixed cost is well. Let's go back and find fixed cost. Here's fixed cost. So fixed cost is fixed as 100. Okay, so we're just going to divide 100 divided by Q. Fixed cost, whoops, I didn't want to circle that. Fixed cost divided by Q. So that would be 100 divided by 0, which is undefined. But then 100 divided by 10, 100 divided by 40, 100 divided by 60, 100 divided by 70. Okay? So, a 100 divided by 0 is, again, it's undefined. But then we've got 100 divided by 10, which is 10. And then we've got 2.5. And then we've got, trying hard to keep the columns in order here. What's 1.6? It's actually 1.67. And then 100 divided by 70 is 1.43, and so on. And we do the same thing with variable costs. Variable cost is, or average variable cost is variable cost divided by Q. Well, here's variable cost. So 0 divided by 0 is undefined. 10 divided by 10, 20 divided by 40, 30 divided by 60, 40 divided by 70, and so forth. And that gives us, well, I'll just write them, okay, undefined there, but here we've got 1, 0.5, 0.5, 0.57, 0.67, and 0.79. And then last, average total cost. Thank goodness, right? Average total cost divided by Q. Well, again, total cost, here's total cost. So that'd be 100 divided by 0, undefined, 110 divided by 10, 120 divided by 40, 130 divided by 60, and so forth. Okay, so that gives us let's see down here, gives us 11, and 3. Now, there's another way to do this. Just as fixed cost plus variable cost equals total cost, average fixed cost plus average variable cost equals average total cost. So we can do it this way. 10 plus 1 is 11. 2.5 plus 0.5 is 3. Okay? Same thing. Either one works. So let's just fill those in. 2.17, 2, 2, 2.11. Now we're going to graph these. So we've got 11 lines we're going to graph. 11. Can you imagine a graph with 11 lines on it? 11 curves? No, we're not going to graph all 11. But what we are, so we're going to choose carefully though. We're going to graph just some of them because we can derive from those the other things we want if we want it. So what we're going to graph on one axis quantity, and we're going to graph a marginal cost. Now here's the thing, why not marginal product? Because we don't need marginal product. Remember, marginal product is inversely related to marginal cost. So we know what's going on with marginal product. When marginal cost is falling, we know that marginal product must be rising. When marginal cost is rising, we know marginal product must be falling. So we know what's going on with marginal product through marginal cost, so we don't really need that. And the emphasis here is on costs. So we're going to graph that. We're going to put quantity on one axis, the horizontal axis, and then we're going to put average variable costs and average total costs on our graph. And from those things, we can get whatever we want. So let me just show you real quick. If we know average total cost and average variable cost, if we need to know average fixed cost, can we get it? Yeah. If we know these two, we can get this. Average total cost minus average variable cost equals average fixed cost. Okay, so we can get average fixed cost. Can we get, let's say we have average total cost, but we want to know what total cost is. Can we get that? Well, sure. Average total cost times quantity here will give us total cost. So if we have the averages, all we have to do is multiply by quantity to get the totals. So we can easily get that from the graph. So we don't need to graph everything. We can get it if we need it from the information on the graph. So that's all we really need. Okay, so I'm going to use those numbers, and I'm going to have to scroll over here where we can't see them. But here we go. Whoops, that is not what I want. I'm going to put Q here. And then I'm going to, well, it's going to take a second here. 0, 10, 20, 30, 40. Okay, and on this axis, we're going to have marginal cost, average variable cost, average total cost. So here we go. Let's go with average variable cost first. When quantity is 10, average variable cost is 1. Okay. Right there. Okay. And when quantity is 40, average variable cost is 0.5. Right there. Okay, so that's what we're doing. We're just simply plotting the points. So we've got, I'm not going to go through every single one, but I just want to show you where I'm getting the numbers. So here we go. Let's speed this up a little bit. So we've got 40 and 0.5, 60 and 0.5, right there. And 70 and 0.57. So it starts to go up right there. 75 and 0.67. Well, wait, so yeah, 0.67. Yeah, 75 right in there, 0.67. And 76 and 2.1, let's see. It's 0.79. So right in here. So we've got this curve coming down, bottoming out, and then starting to go up again. That's average variable cost. Okay, average total cost. You can do the same thing. When output is 10, average total cost is 11. Okay, so it's way, way up here. I'm going to just put it up there. When it's 40, average total cost is 3. About there. 60, 2.17. Right in here. 70 is 2. Right there. 75 is 2. Right about right there. And 76 is 2.11. About there. So this comes from way up here, comes down, bottoms out, and then starts to go up again. There's average total cost. Now, marginal cost. Just as we plot the marginal cost between the numbers, between the quantity numbers, as we're moving from one output level to another, we're going to plot the graph between the numbers. So as output goes from 0 to 10, marginal cost is 1. So we'll pick a midpoint here and plot the 1 right there. As we go from 10 to 40, marginal cost is 0.33. So pick a midpoint right in there. 0.33, that would be down there. Okay, and I did not mean to. Okay. And as we go from 40 to 60, marginal cost is 0.5. 40 to 60, we pick a midpoint, which is 50, and 0.5 is right about there. And 60 to 70, marginal cost is 1. Pick a midpoint, 1, right up there. And 70 to 75, marginal cost is 2. Pick a midpoint between 70 and 75 and plot 2, right up there. And, well, actually, I think that's supposed to be right there. My graph isn't very good, as you can see, not precise. And 75 to 76, marginal cost is 10. So it's way up here. So marginal cost comes down like this and cruises up like that. Okay, well, that wasn't pretty, but it did the job. You're going to see this graph a lot. And the main point here is that as long as marginal cost is below average total cost, this is the average total cost curve, as long as the marginal is below the average will be falling. So marginal is below the average. Now marginal is rising through here, but it's still below the average. So at this point it's rising, but it's still below the average, so the average is still falling. It's going to cut through the bottom, the minimum point of the average, and then marginal cost rises, and notice when marginal cost is above the average, it pulls the average up. Same with average variable cost. As long as the marginal is below the average is falling, but then it cuts through the bottom, and when marginal is above the average starts to rise. Now that makes perfect sense. Think of it this way. Let's say the average height in the classroom is 5'6". We measured everybody, and we divided by the number of people, and the average height is 5'6". Someone 6 feet tall walks through the door. That's the marginal person. That's the last one, right? The last person, the marginal person. Now we're going to add them to the mix, and we're going to recalculate the average. Well, what do you think is going to happen to the average? The last person in the door is higher than the average, so that's going to pull the average up. And the same if the next person walking through the door is 5 feet. They're below the average, they're going to pull the average down. That's why when the marginal is below the average is falling. When the marginal is above the average is rising. The other big takeaway here is why does marginal cost fall, then rise? Well, I already told you the answer to that. It's because marginal product rises, then falls. That's why. So we know exactly what's happening. If marginal costs are falling, we know marginal product is rising. We've got increasing productivity through this range. But when marginal cost starts to rise, we know that there are diminishing marginal returns going on. And that's why we're going to see that with any production process. We may or may not see falling marginal costs or increasing productivity, but we will certainly see eventually diminishing marginal returns, which we can see manifested in the rising marginal costs. So we've only got 3 lines here to deal with. We've got marginal cost, we've got average total cost, we've got average variable cost, and we can get anything else we want. If we want total cost, we can simply take the average and multiply it by Q to get total cost. If we want total variable cost, we can just take variable cost and multiply it by Q. If we want average fixed costs, we can, what's the difference between, well, average fixed cost is the difference between average total cost and average variable cost. So average fixed cost will be this distance right here. Average total cost minus average fixed cost. Excuse me, average total cost minus average variable cost gives us average fixed cost. And if we want to know total fixed cost, once we calculate the average fixed cost, we can just multiply it by Q. So we can get anything we want out of here. Really, we just got 3 lines, but it gives us all the information we need and yet makes the model manageable. Remember, we want simplicity. We don't want more detail than is necessary. And this is all we need. Now, this is the firm's, if I asked you, is this in the short run or the long run? Are these cost curves modeling the short run or the long run? Well, why is the marginal cost falling and then rising? It's because marginal product is falling. Excuse me, marginal product is rising, then marginal product is falling. Why do we have diminishing marginal returns when marginal product is falling? Because we're adding a variable input to a fixed input. We're saturating that fixed input with more and more and more of the variable input, which makes marginal costs rise or marginal product fall. In the long run, there is no fixed input. In the long run, all inputs are variable. Okay, so this is the short run. These are our short run cost curves. And we're going to use these cost curves in the next 2 or 3 chapters to analyze the firm's behavior. Okay. So, from now on, we aren't going to go through all the whole big thing that we just went through, or at least not to that extent. What we're going to do instead is I'm just going to come in here and we're going to plop this down, marginal cost, average variable cost, average fixed cost in this axis. And we're going to draw the average variable cost curve. We're going to draw the average total cost curve. And then we're going to have the marginal cost cut through the bottom of those. There we go. That's what we're going to do pretty much from now on, is just draw them in. Because we know why average variable cost falls and then rises. It falls and then rises because marginal cost is below average variable cost when it's falling. And average variable cost is rising when marginal cost is above average variable cost. We know why average total cost falls and then rises, because marginal cost, when marginal cost is below average total cost is falling. When marginal cost is above average total cost, it pulls the average up. So that's why they're shaped the way they are. Now, why is marginal cost shaped the way it's shaped? Why is it falling then rising? It falls because of increasing productivity, increasing marginal product, and then rises because of decreasing productivity or decreasing marginal product. And why is marginal product decreasing? Because we're adding a variable input to a fixed input, and we're getting less and less added output as we increase our variable input, as we exhaust that fixed input. So that's why they're shaped the way they're shaped. It's modeling those features. This is essentially, because it's marginal cost that drives the shape of average total cost and average variable cost, everything's being driven here by marginal cost, which is, of course, a mirror image of the marginal product. So this is a picture of the law of diminishing marginal returns. This is it. This is what it looks like in terms of costs. That is a photograph of the law of diminishing marginal returns as far as cost curves go. So we want everything translated into cost. Now the next thing we're going to do is we're going to add revenues. We've got our cost curves, and in the next chapter we're going to do revenues.